Okay, these are the absolute value functions. IXL we're going to do, DD.1 and DD.2. So they're right here, and I'm going to show you a couple examples of each. So in the first one, DD.1, what you need to do is simply finish the table. So f of r means absolute value of r. In other words, given this value, you need to find it according to this formula. So in the first case, just the absolute value. Absolute value of -1 is +1. Absolute value of 0 is 0. Of 1 is 1. And of 2 is 2. So start out quite easy. Now we're going to find the absolute value of 2d for a given d. That's what this function notation means. You take this value and you plug it into this formula, and you write the result here. So 2 times -4 is -8, and take its absolute value, you get 8. Similarly, for -3, you get -6, absolute value, which is 6, then 4, then 1. I'm sorry, 2. Each of these you double, and you make it positive. And the reason that you might do this is to get a table where you could then graph the values. All right, let's do one more. So 4 minus 6 is -2, absolute value of +2. 6 minus 6 is 0. 8 minus 6 is 2. And 10 minus 6 is 4. You can see here this idea of it going down and then back up again, which is a characteristic of absolute value functions. All right, let's move on to the next one, which was DD.2, graph an absolute value function. So this is the absolute value of x minus 9. So one way you can always think about graphing is to make a table, kind of like we did before, right? So you want to find values of x that are close to the origin, and then find the corresponding value of y. So let's try -2, -1. If you don't know which values to pick, you can pick different values, but these ones very close to the origin are usually good. Sorry, this should not be negative. That's just 1, and that's 2. These values that are close to the origin to the 0, 0 are usually good ones to do. So now for each of these, -2, absolute value of -2 is +2. 2 minus 9 is -7. Okay, so I have a point on the graph here at -7. I'll go back and graph them when I'm done with this. -1, absolute value is 1, minus 9 is -8. At 0, -9. 1, absolute value of 1 is 1, minus 9 is back to -8. You can see this effect here where if I go down, you hit a bottom, and then you start going back up kind of in the same way. And at 2, I get 2 minus 9, which again is -7. So the effect that we see here, it's a nice pattern actually. At -2, and I switched over, so now if I click on the graph, I can just plot these points. At -2, I'm at -7. Oh, it says plot the vertex first. My mistake there. So I'm going to undo what I did here because it's expecting me to start with the vertex, which is this point. The one where it hits its minimum is called the vertex, right? So I'm going to start there at 0, -9. And then I'm going to plot, and it actually does a lot of the work for me. even though I've made this whole chart, I only really need one more point, and then it's going to go straight line each way. So, but we can see how this works. So for example, one of the points that we said was 2, -7, which is this guy right here, 2, -7. I click on that, and you'll see that the other points are where expected. -2 is at -7, -1 is at -8. So I can have a pretty high degree of confidence that I've got this one right. So I'm going to go ahead and submit. All right, so this is the sort of the easiest case, right? If I have this, which is simply y equals absolute value of x, that's what we call the parent function. Actually, I probably could have left my x's and just rewritten my y's. But in this case, it's pretty easy to determine the numbers. At -2, y is +2. At -1, it's 0. Again, this is a little bit of overkill given what I need to accomplish here. Oh, wait, sorry. I don't know why I said 0. -1, my answer is 1. I think my brain was getting a little ahead of me. At 0, it's 0. At 1, 1. And at 2, 2. So where does it hit the minimum? In other words, where's the vertex? That would be right here. And it wants me to start with my vertex. My vertex is 0, 0. And I can pick one more point off of here and graph it. So I'm doing a little more work than I need to do, but for now, it's a good way to get a good idea of what's going on. All right, so at 1, 1, I could graph that point. I could graph the point. -1, 1, I could graph -2, 2, 2, 2. Any of those points would work. You'll notice that they are all on the graph. So reminder, we do the vertex first for this, which is the point where it changes from a negative slope to a positive slope. So hope that helps. We got that one now as well. All right, we will leave it there. Hopefully those videos were useful for you. Thank you.